Materials are purchased on a per pound basis, but employed on a per cubic inch basis. Cost per cubic inch offers a good first approximation when the comparison is restricted to die casting alloys. When comparing with other materials that have significantly different properties, material forms, and manufacturing methods, cost per cubic inch must be considered with several other factors. The purchase price of die casting alloys per cubic inch is generally higher than cast iron, equivalent to comparable foundry alloys, powdered iron, sheet steel, and lower priced plastic, and lower than copper alloys and higher priced engineering plastics. Ingots are one of the common material forms that die casting alloys are purchased in before being melted to produce die castings. The die casting shown is resting on ingots of the same alloy used to cast it. Die casting alloys are purchased on a per pound basis. The major in-plant processing cost associated with die casting alloys is the energy required to melt them. Melting costs are generally equivalent to comparable foundry alloys. Energy costs are lower for those alternate processes that require heating without melting, such as powdered metal, and processes that require no heating, such as stamping and automatic screw machining. In-house die casting scrap consists of rejected castings and the metal that solidifies in the metal distribution system of the die casting die, which is subsequently trimmed off and returned to the melting furnace. The die casting process benefits from the ability to reprocess virtually 100% of its scrap. The reprocessing cost, primarily the cost of energy required to remelt, typically adds 5 to 10% to the material cost for die castings. Foundry alloys and some thermoplastics incur similar costs. Scrap from thermosetting plastics and stamping processes usually cannot be recycled in-house. Powdered metals generate essentially no material scrap. Screw machining will generate significant amounts of scrap and is discussed later.